All right, well, let's go ahead and get started. Thank you all for joining our session today in track 2. Today's session is all around automated testing, driving quality forward. And I'm excited to introduce to you VG. VG is an enterprise architect, technical director at Veracity. She is also a director in Women Who Code RVA chapter. With a master's degree in computer science, VG started her career as a software developer. Her experience spans software architecture, delivery, DevOps, and people leadership. In her current role at Veracity, VG's leading technology and digital transformation for clients, passionate about all things technology, and is a firm believer of Women Who Code vision and mission. So with that, VG, welcome, and I'm going to pass off to you to get us started if you'd like to share your screen. As a reminder, please use the Q&A box to ask any questions, and we'll do some Q&A at the end for a chance to win some RVA Tech EarPods.
Thank you, Courtney. I am going to start my screen share. And once again, thank you, Courtney, for that great introduction. And also thank you, RVA Tech, for all that you do to give us a platform to collaborate, share, and grow our skill sets, and also grow the professional network in the Richmond, Virginia area. So thank you for that. Very grateful to have the opportunity to speak and learn from each other here. And today, what I would like to talk about is automated testing. Just share some ideas and best practices around software testing in general, and how automating it is crucial to a quality software product. So I would like to jump straight into the topic of the day. And this isn't a new concept to us, I'm sure. We know that there are different phases in software delivery, and testing has always had a place in SDLC. And, you know, the concepts for software testing are pretty much the same, whether you're doing manual testing or automated testing. And where they really differ is in how the tests are executed. And you definitely need a human to basically understand your requirements. You need a human to interpret the results. And the way we actually execute the scripts is where the difference lays. And it's quite normal when we talk about test automation to hear a whole slew of types of testing and their purpose. So what I would like to touch on next is what are those different types of tests and their purpose? And what should you actually be considering for your application, however big or small it is? Well, that it depends on the type of architecture that your system has and the types of defects or errors that your system is potentially bound to encounter. So what I wanted to do here is share a very simple application architecture for a 3-tier microservices based application. And it's possible that the area that you're supporting isn't really focused on the entire application. You might be responsible for a certain aspect of the application. So what I have here is the architecture for an application that is built on AWS. And this if you imagine this to be a customer-facing web application, you typically have your customers interacting with the application through a web tier. And then your web tier basically reaches back to your application tier for business functionality or interacting with data which is usually in a transactional relational data store. So um, when you have an application that is of this nature, where you are looking for high availability, high response time from your application, you have to look at the components that are critical. And in this case, I would like to start first with the microservices layer. You want to make sure that anytime a change is made to a microservices component, that it doesn't break the application, or it does not introduce compatibility issues with the other microservices that are operating in this ecosystem. So that's one thing to watch out for. Another thing to also watch out for is websites are very vulnerable to cross-site scripting injection, SQL injection, DDoS attacks, and you want to make sure that you are testing your application for security, whether it's static security testing or dynamic security testing. Now, this doesn't imply that microservices are exempt from static security testing. They do qualify for those types of tests as well. And another thing to look at is scalability. If your application faces seasonal high volume, where you go from normal business volume to 4x during certain time frames of the year, or even certain time frames of the day, there's a drastic difference between your daytime and nighttime traffic. You really want to look at implementing an on-demand auto-scaling type of an infrastructure. And you need to make sure that you test your application and make sure that it doesn't break, or your microservices don't crash anytime there is an increased capacity demand on the application. And the way we do that is through performance testing. And another another luxury that we basically have on the cloud is being able to create and stand up infrastructure on demand. And that brings along with it potential errors in deployments and errors in how your infrastructure resources are actually um, are interacting in whether you have the right security policies and compliance policies that have been set for the organization by your security officer. So, and there are some tools available where testing at that infrastructure level can be instrumented, and they come in handy to protect us from deployment issues. And another concept that is fairly new is the concept of chaos testing, where if your application, especially is on the cloud, and you um, are an application that expects high reliability and resiliency, you want to make sure that your application can self-heal and can basically withstand disruptions. And chaos testing is a very good way to protect the application from those types of issues. So this is quite a lot, and instrumenting all of these types of tests is not a trivial effort, and it does take investment and also an understanding of um, what each one of these tests are. However, all of these can be automated. So there are tools and techniques available in the market that let us automate all of these types of testing. Um, and if you look at some of the types of testing I talked about a little bit closer, in terms of what they do, what types of tools are available in the market, this basically should give you an idea of um, the concepts and also some of the tools available. Unit testing really comes in handy for your shared components, especially if they're changing quite frequently. um, you want to make sure that you pick the unit testing tool that is appropriate for the language um, that the code is written in. You want to look at component testing, which is basically your integration tests to ensure that your components really are talking to each other properly. They are able to handle the input and the output conditions that your components are coded for. Usually, um, you have frameworks like Java, Cucumber, Ruby Cucumber. I also combined user interface testing along with the component testing, where you basically have the ability to validate the graphical user interface elements on your application. You can basically test your application for accessibility. Um, and cross-browser testing. So those types of tests will basically be part of your component tests. And usually people talk about functional testing, component testing, system tests, regression tests, all of that in that same vein. Performance testing, we looked briefly at how it helps maintain a certain capacity expectation for the applications. The way we do that is by testing the application for load, and you also test your application for endurance. You basically and validate that any change you make to the application really doesn't impact the application's performance after X amount of time. So you run endurance tests over a certain amount of period, like 24 hours, 48 hours at a certain capacity to make sure that the performance doesn't degrade over time. Infrastructure testing, this is a fairly new concept, which basically has been enabled by operating on the cloud. You do have frameworks that are out there still, which they might not be all encompassing and comprehensive. However, there's quite a few tools out there that can do really good validation of some of the um, very fundamental infrastructure validation tests. And some examples are provided by HashiCorp, that basically provides your Terraform functionality for standing up infrastructure. There's also AWS owned AWS spec or tools framework available as well. We talked about security testing briefly. All of these concepts are somewhat deep. Hopefully, this is giving you an introduction to those concepts where you can then go and do research on your own. Security testing, basically, there are different types of security testing. You can test your application for static security, where you don't execute the code. You have tools that will just inspect the code and basically provide recommendations based on potential conditions where you can run into like a buffer overflow, or like I was talking about earlier, cross-site scripting. Validate there is input sanitization happening within the code. And there are tools that do this in the market. Fortify and White Source are pretty popular. And I have had some experience with another tool called Arachne that does dynamic security testing as well. And they are great tools to explore. User experience testing is something that is hard to automate. And this is really something that a human usually needs to participate and run the tests, because you're basically looking at, is my website easy to navigate? Is the product description clear on my website? And usually, it's not up to one individual to determine whether a website is easy to navigate or not. And usually organizations use the concept of A/B testing, where they have multiple experiences and they let the end user behavior kind of inform the success or failure of a certain experience. So there are tools that are available to do that kind of A/B testing as well. Chaos testing, like I was saying, is a fairly new concept, and it's all about in introducing faults and also checking if your application is able to self-heal. And Netflix is the inventor of that type of concept, and they really taught us how to actually go about instrumenting chaos testing. And there's documentation on how that's done as well. Now, what I wanted to talk about is if you are looking at a whole slew of testing approaches, tools, and frameworks, how do you determine what's the return on investment of all of this? And what I would like to suggest is just look at the sheer volume of the test cases that you have to execute. And usually, as a rule of thumb, as your number of test cases increase, you want to go from a manual to automated fashion of executing these tests. And generally, just statistically speaking, your test cases, number of test cases are highest when you are instrumenting unit test cases, and then they just go decreasing in number as you go from unit test to component test to chaos test to user experience tests. And one thing to also keep in mind is just basic return on investment calculation would be how much time am I spending on writing test cases and executing them? How often do I do this? And really, what's my estimate on um, how long that would take to automate the test case and execute the automated test case versus how long does it take to execute it manually? So it's just a simple calculation is what I would like to propose. There are lots of ideas around how to be very specific about calculating return on investment. However, one thing to really think about is not just from the perspective of dollar value, also look at customer trust. If you really are dependent on manual testing, there's a risk involved in human error, which results in defect leakage. So you want to make sure that you factor that. You also want to factor resource productivity. If you have a testing, a tester or a test engineer using up his or her time to execute manual tests, what's that productivity look like when you compare that with them actually picking up a new skill and automating multiple test case suites versus just spending a lot of time executing manual tests. So another thing we talked about, rate of change. Complexity is another thing to factor. Sometimes applications are just harder to automate the testing, and it's complex, so you really have to break it down to understand which aspects of that application are truly have that true potential for automation. And table stakes, we really need to know how to manually test the application first. So we have to figure out how to do it manually, and then comes automation. So I'd like to talk about how often, when do you trigger the automated test? As often as early as you can, as and when change happens is the best practice. We have seen the old-fashioned linear way of executing tests where we code for X amount of time, but then test for like 3X amount of time. And I used to call this the long tail in the software delivery process. And there's a clear handoff from the developers to the testers in this case. And one thing that the DevOps culture really taught us is actually moving away from something like that into a continuous integration, continuous testing, and continuous deployment methodology, where code is actually getting tested in every step of the way. So when the code is being built by the developers, we want to make sure we execute certain tests. When the code is being merged with the feature branch or main branch or whatever your branching methodology is, you want to make sure you run a battery of tests. When the code is deployed to an environment, you want to make sure you run a battery of tests once that happens. So this is a really good way to make sure that we have been able to follow the best practices of shifting left in your testing cycle, where testing is really not coming right, at the tail end of the end of development. And this really helps us increase transparencies, because as you're executing the tests and sharing the test results, and this goes hand in hand with Agile and DevOps. So you do see a lot of benefit in executing your tests continuously. And I know this is an eye chart, and this is typically what a robust CI/CD pipeline looks like. The only thing I wanted to point out here is, if you look at testing, which is the purple bubbles, you look at how many purple bubbles you see in this pipeline. There's way more than the other steps that you see, which are nothing but the automated way of executing your entire SDLC process. And this is the holy grail of DevSecOps. And if you looked at the emphasis that is placed on automated testing, it's pretty clear that automated testing plays a really crucial part in striking that balance between quality and speed when you are really talking about a DevSecOps or Agile transformation, or any of those methodologies that are very popular for delivering software currently. So this is my last slide. What I wanted to really talk about is where to start. And I wanted to walk through a very simple playbook for what would be a great way to get your feet wet if you're new to automated testing. And if you're looking to just add certain elements to your automated testing, this hopefully helps with that too. The first and foremost is commit to it. Testing is quality. I think we have to test no matter what, whether it's manual or automated, because we want to ensure that the products that we are releasing are of utmost quality. And quality has so many implications that go along with that. Evaluate how often your application changes and what's the cost to really go back and do a little bit of business case. So this can be if you have to get budget, if you have to talk to your boss for resources, you at least have some a business case that you can actually go back to and use to refer. And start with a simple component if you're new to automated testing. Even better if you pick a component that is reused across the application. One example is authentication. If you're a website that basically allows people to sign in, sign up, there are several things that happen as part of that process, and that would be a very good component to pick up and try to automate. And first of all, just make a list of the types of tests that are relevant for that component, and then start identifying the tools and frameworks. And I have an example at the bottom here. Of course, you will have to retool. There are lots of training materials, thanks to lot of communities out there that share expertise in the automated testing space. There's a lot of self-help type of material available, and most importantly, invest in a CI/CD pipeline, a continuous integration and continuous testing pipeline. And I have given a sample set of tools here. And open source would be a great way to start. And then as you scale up, think about enterprise licenses and enterprise scale solutions. And right from the get-go, make sure that the metrics from the automated testing scripts are being collected on a very simple tool. What I have here is a Grafana dashboard, and Grafana is pretty interoperable. It can basically talk to your unit testing tools. You can basically it can ingest metrics from any of your automated tests, and you should be able to visualize metrics. So this is a very good way to really demonstrate the value um, of your automated tests. So hopefully that gives a good idea of like what automated testing is, soup to nuts, or at least gave you an introduction to the concepts. And basically, that concludes my talk, and I'm open to questions at this point.
Great. Thank you, VG. This was a great presentation. I think it stirred up a few questions. So thank everybody for submitting your questions. As a reminder, you can use the Q&A box. The first question I wanted to ask you, VG, comes from Kelly Genova. If your application exists on the cloud, are certain types of tests not applicable, such as load testing, security testing? Could you comment on that?
It actually, they are still very much applicable. So we do have to do load testing and validate the assumption that your application can auto scale, because the cloud providers do give us the capability to scale up on demand. However, it's up to the application developers to make sure that those capabilities are being used appropriately by our application. There's still a responsibility as an application owner to make sure that the application scales up, even though we're on the cloud. Things are getting easier and more automated on the cloud. So there are platform as service tools that AWS and Azure provide that make it easier for us. And more and more not in our hands. Still, we still have that responsibility to test and make sure it's working as expected.
Great. And I think we have time for one more question. Kelly, I will say, I think that was a very good question. So congratulations. You are the winner of our free RVA Tech earpods. The next question I have comes from Allison Clements. Any recommendations on encouraging the company to adopt automation testing? My experience is that management views short-term ROI instead of more realistic long-term ROI.
Yes, and that's a very tricky question, a very real one that we all face. You definitely need a champion at the senior leadership level, and it's very hard to um, influence bottom up if that buy-in at that senior leadership level isn't there. It definitely pays off in the long run. Usually, what I have seen is just bringing in some industry experts and having them kind of, it's not even, it doesn't even have to be the employee. Usually getting an industry expert and just having them do an assessment of the current state and providing a readout to your leadership team. I've seen that work really well, and it's very hard as an employee if you're trying to influence up. There's very it's hard to make that big impact.
Great. Thank you so much, VG. I hope everyone got a bunch of information they can take back, a couple little tidbits to take back to their companies. We're looking forward to the next session. So we'll go ahead and close and say thank you so much to VG. And if you stay on this line, we will get started with the next track session, which is going to be about a checklist for developers. So thank you so much, VG. We appreciate your time today.
Thank you.